iterative construct can also be transformed to a recursive approach. First, to see what is a recursion. Recursion means a function calls itself. A function calls itself, that is said to be a recursion. A function can call itself, that is said to be a recursion. Suppose f is a function, the function f is being called inside the function f, then this is said to be a recursion. Whenever you call a function f, assuming that some executable statements are there, after that you are calling the same function, so control again invokes to execute the function f. So in case of recursion, what are important things? Actual parameters. Actual parameters. Second one, formal parameters. Suppose f is a function with actual formal parameter is x. Here this x is a formal parameter. Consider a recursive call, some f of x minus 1 initially assume the function call f of 10. What is this 10? 10 is the actual parameter. 10 is the actual parameter. The actual parameter 10 is assigned to the formal parameter, so that here x receives the value 10. So initially you are calling f of 10. Now here, for example, f of x minus 1 means this becomes f of 9. Now what happens? F of 9, right, further invokes the function, same function f. So that stage what will happen means this 9, right, f of 9, this is a calling statement. In this 9 is the actual parameter. Now the updated value of actual parameter is 9. This 9 is passed to the formal parameter x. The new value of x is 9. Then f of x minus 1, right, suppose x is 9, then f of x minus 1, 9 minus 1, next stage f of 8. Then what happens? New actual parameter is 8, so that the formal parameter x receives a value 8. So this way the function calls, right, continues. Initial call is f of 10, then f of 9, say f of 8, f of 7, etc., f of 6, 5, 4, 3, 2, 1, f of 2, f of 1, f of 0. In one stage we need to clearly specify the termination condition. So in recursion, right, another important thing is specifying a termination condition. That means when to terminate the recursion, that is a termination condition that should be properly defined. Suppose when x becomes 0, right, for example here I write a statement, if x is equal to 0, then return x or something, right, return exit something, else you can write a statement something f of x minus 1. So this way, right, you need to specify one termination condition. If no termination condition is specified, what will happen means the function will be called infinitely, right, over a time. For example, f of 0, no termination, then f of 0 will become f of minus 1, f of minus 2, etc. Right? So this goes on, infinite calls will be made, no termination will be, because one important criteria of an algorithm is termination, right? After some finite executable amount of time, algorithm must terminate its execution. So in recursion, right, carefully specify the actual parameter, and when you call the same function here inside the function definition, clearly update, right, the actual parameter in the new function call, right? So actual parameter and the relationship actual to formal parameters, number of parameters, right, should be the same in actual and formal parameters, and above all the termination condition that should be clearly defined. These are the important things to be considered in designing the recursive construct of the given algorithm. Already we have seen the sum algorithm, which finds the sum of the elements stored in an array. In that algorithm, right, we have evaluated S is equal to A1 plus A2 plus A3 plus etc. An. Now let us try to write the recursive construct to evaluate the same expression. Let us write the algorithm. Name of the algorithm is, for example, a recursive sum. Previously we have designed the iterative construct algorithm sum A array comma n. What is the explanation on the parameters A array? A is a one dimensional array. A from 1 to n is a one dimensional array which consists of n elements, A1, A2, A3, etc. An. Algorithm recursive sum, right? This is the name of the algorithm, A array comma n. Opening curly brace. Algorithm starts here. Let us define a termination condition. Suppose if n is equal to 0, then let us return a value 0, else return A array. What is A array? We need to use the algorithm name, then a parameter should be introduced. Return recursive sum A array comma n minus 1 plus A of n, semicolon, opening curly brace, closes here. This is the end of recursive sum algorithm. Now consider this algorithm. Algorithm name is recursive sum, which takes the formal parameters A array comma n. Initially, right, n elements are passed as input parameter to this recursive sum algorithm. Capital A is a one dimensional array which consists of n elements. We need to find the sum, right? S is equal to A1 plus A2 plus A3 plus etc. An. If n is equal to 0, then the value to be returned is 0. Else return recursive sum A array comma n minus 1 plus an. Have a look into this expression, recursive sum A array comma n minus 1. This is clearly a recursion. Same function, right? Recursism is mentioned here. Here also recursism. Parameters are changing. Initially, right, formal parameters are a array comma n. Now the new actual parameters are a array comma n minus 1. That means in the initial call we are considering the first n elements, but in the first recursive call we are considering the first n minus 1 elements in the array. What about an means, right? An is added with this recursive call plus an. Return recursive sum of a array comma n minus 1 plus an. The nth element is added with this recursive call, then the entire result is, right, evaluated. Finally that expression, that means the right hand side of this equation, s is equal to, that is evaluated here, and the value is returned to the calling place. For example, the algorithm returns the value of s is equal to a1 plus a2 plus a3 plus etc. an. What about the termination condition? When n becomes 0 in the actual parameter, right, the expression, right, a array comma n minus 1. Initially n is 10, 10, 9, 8, 7, 6, etc. 5, 4, 3, 2, 1, 0. When this parameter, right, n minus 1 here, when this value becomes 0, what happens? No more execution to be taken place. So return a value 0, return 0. This is a termination condition of this recursion. Let us verify the correctness of this algorithm. For example, take same for n is equal to 5. What is the initial call? Recursive sum a array comma 5. This is the initial call. N represents the number of elements in the array. N is equal to 5. What is the condition to be tested? Checking if n is equal to 0. Now n is not equal to 0, since n is equal to 5. N is equal to 5 and n not equal to 0. In that case, what happens? Return recursive sum a array comma n minus 1. That means I write here return recursive sum a array comma n minus 1. What is the current n? N is 5. 5 minus 1, 4, plus what is a of I, a of, sorry, what is a of n? N, right, this is taken from this formal parameter n. So plus a of n, n is 5, a of 5. Now return recursive sum a array comma 4. What happens? This is a recursive call. This recursive call calls the same function with the actual parameter, right? Actual parameter is 4. Now what happens in the function definition? A array comma n, that n receives a value 4. N is equal to 4. So now check if n is equal to 4. This is not equal to 0. This invokes a recursive call, recursive sum a array comma n minus 1, right? N minus 1, current n is of 4, 4 minus 1, 3, plus a4 is separated. Next, this recursive sum a array comma 3, this invokes the same recursion. N becomes 3, 3 is not equal to 0. So this calls the next recursive call, recursive sum a array comma n minus 1, since n is 3, 3 minus 1 2, plus a2 is separated, a2. Next stage, n is equal to 2, formal parameter, n becomes 2, 2 is not equal to 0. This invokes the next recursion, recursive sum a array comma 1, four, 5, 3, 4, or 2, this is 3, a2, a3, then a1, a2 is separated. Next stage, current n is 1, which is not equal to 0. This invokes next recursion, recursive sum a array comma 1 minus 1, right, 0 plus a1. Next, this invokes the next recursive call, same. Now, what is the value of n? N is equal to 0. What is our logic? If n is equal to 0, then return 0, right? This if, right, can also end with end if. If n is equal to 0, then return 0, else return this expression if end if. Now, what happens? Current n is 0. Current n is 0 means first checking if n is equal to 0, then return 0. So, this recursive call returns a value 0. So, returning 0, return of 0, this indicates that 0 plus a1, this is equal to a1. So, a1 is returned to the calling place. Who is the caller of recursive sum a array comma 0? Recursive sum a array comma 1 is the caller. So, the value a1 is returned to here, then return a1, here also return, then return, right, the value of recursive sum of a array comma 1 is a1, a1 plus a2, this implies return a1 plus a2. Who is the caller of a recursive sum of a array comma 1? Recursive sum a array comma 2 is the caller. So, here when the control returns recursive sum a array comma 2 plus a of 3, the value a1 plus a2, this is returned here. So, this is equivalent to return a1 plus a2 plus a3. Now, the caller of recursive sum of a array comma 2 is this one, recursive sum of a array comma 3. A array comma 2, right, returns this expression. So, here this is equivalent to return a1 plus a2 plus a3 plus a4. Now, the caller of recursive sum of a array comma 3 is this recursive sum of a array comma 4. Now, this value is returned here, then the first return statement, return recursive sum a array comma 4 plus a of 5, this implies return a1 plus a2 plus a3 plus a4 plus a5. So, have a look into this expression, recursive sum a array comma 4, the value to be returned, right, in the recursive call of recursive sum a array comma 4 is a1 plus a2 plus a3 plus a4, and the value a5 is added, and finally the entire expression is evaluated and is returned to the calling place. So, that this recursive sum a array comma n algorithm finally returns the value return a1 plus a2 plus a3 plus etc. an minus 1 plus an. The entire result is evaluated and the value is returned to the calling place. Just think of how many times the recursive calls are made. Initial call is for n is equal to 5, recursive sum a array comma 5. This is the initial call. Further recursive calls are recursive sum a array comma 4. This invokes the recursive call recursive sum of a array comma 3. This invokes the recursive sum of a array comma 2. This invokes a further recursive call a array comma 1. Then the next recursive call to be made is recursive sum a array comma 0. So clearly one initial call when n is equal to 5, the recursive sum algorithm is called how many times? 1, 2, 3, 4, 5, right? 5 times the same recursive procedure is called. Normally recursion is evaluated using stack, last in first out, LIFO logic. Stack is used to evaluate the recursive constructs, recursive evaluation. Since initially n is equal to 5, recursive sum a array comma 5, here 5 represents the formal parameter of the algorithm. In the algorithm, the formal parameter n is updated to n minus 1 in its first recursion. So clearly a recursive sum of a comma 5, this invokes recursive sum of a comma 5 minus 1 of 4. Then the next recursive call, the formal parameter is decremented to, this is 4 minus 1, 3. Next recursive call, the formal parameter is decremented to 3 minus 1, 2. Next stage, recursive sum of formal parameter is here 2 minus 1. The next recursive call formal parameter is here 1 minus 1. When the formal parameter is 0 or in the recursive call, here the actual parameter is 0. Clearly this actual parameter is assigned to the function call recursive sum a array comma n, so that the formal parameter n becomes 0. The statement to be executed is if n is equal to 0, then return 0, so that no more recursive calls will be made. The recursion terminates because of returning the 0, returning a value 0, right? Here this value is returned to here, then this resultant value is returned to here, this resultant value is returned to the previous recursive call, and this resultant value is returned to this recursive call, and this value is returned to the initial call, so that the value to be returned is finally return a1 plus a2 plus a3 plus etc. an, right? Currently n is equal to 5. Similarly, when n becomes n, then the expression to be evaluated is a1 plus a2 plus a3 plus etc. an. The sum of first n elements or the sum of n elements which are stored in an array is computed and the value is returned to the calling a place. So understand, this is the logic of a recursive approach. This algorithm also produces the same result as that of we already designed the sum algorithm, sum a array comma n. Same result is produced in the recursive approach.